Good morning, everybody. I hope you all are doing very well. So keep yourself healthy in the same way and start preparing yourself for your exams. As we know that your exams are approaching, so please try to do your hard work in order to achieve your goals. So let's begin with today's topic of revision, that is how to write the formula of the molecular compounds. Now, today we are going to revise that how to write a formula of a molecular compound. But we know that to write a formula for a molecular compound, we should know about valency. And what is this valency? In simple words, we can say that valency is the charge which is present on an ion. We know that ion is formed when any atom lose or gain the number of electrons. So, how many number of electron lost or gained by any atom is considered as its valency along with the charge on that ion, right? But the question arises in our mind, how can we find out the valency? So let's understand by some example that how can we find out the valency. Then we will proceed for the examples of formula of molecular compounds. Now let's discuss some of the example to understand how can we find out the valencies. Our first example is hydrogen. We know that the atomic number of hydrogen is 1. So here we need to fill only one electron in the shell, which will be coming in K shell, right? But according to rule, the K shell should have maximum 2 electrons. So here instead of gaining 1 electron, hydrogen will lose this 1 electron and will acquire positive charge. And we know that only 1 electron is being lost by hydrogen. So we will be writing here, along with the sign, we will be writing here 1. So the charge on hydrogen will be plus 1. And this will become the valency of hydrogen ion, right? Let's understand our second example, oxygen. As we know that oxygen is having atomic number 8. So we have to arrange these 8 electrons in the shell. So in first shell, 2 electrons, and in L shell, maximum 8 electrons can come. But here we are left with only 6 electrons to arrange. As we can see that in the last shell, there should be 8 electrons, right? So in order to make it 8, it need 2 more electrons, right? So instead of losing these 6 electrons, which require more energy, oxygen atom will gain 2 electrons, which require less energy, right? So here when it gains 2 electrons, so we will be writing minus sign, okay? And how many electrons it will gain? 2. So we will be writing minus 2. So minus 2 will become the valency of oxygen ion, okay? The next we are having sodium. Its atomic number is 11. So we are having its electronic configuration 281. 2 plus 8, 10. 10 plus 1, 11, right? Okay, as L shell can maximum have 8 electrons, so the last electron will be transferred to M shell. Now in the large shell, there should be 8 electrons according to octet rule, but here we are having only 1 electron. So instead of gaining 7 electrons to make it 8, it will lose this 1 extra electron, which require less energy, right? So sodium will lose this extra electron from its M shell. So when the sodium will lose 1 electron, it will get positive sign. And how many electrons it will lose? 1. So the charge on sodium will be plus 1. Got it? Is that clear? So the valency of sodium will be plus 1. Now magnesium, the same way 282. It's the electronic configuration. In the large shell, 2 electrons are there. So magnesium will lose these extra 2 electrons in order to attain the stability. Okay. As you can see, by losing these 2 electrons, L shell will be the large shell then. And it is already having filled electrons. So plus sign, which shows that magnesium has given its electrons. And how many electrons? 2 electrons. So the charge on magnesium ion will be plus 2. And this is the valency of magnesium ion. Okay. Calcium. 2882. Why we have written 2 in N shell? Can we write 10 here in the M shell? No. In K shell maximum 2 electrons can come. In L shell maximum 8 electrons can come. And if we will be writing remaining 10 electrons in the M shell, it is against the octet rule. Because according to octet rule, the last shell should have maximum 8 electrons. Okay, not more than that. So we need to transfer extra 2 electrons in the last shell, that is N shell. So according to this rule, the last shell should have 8 electrons, but here only 2 electrons are left. So calcium again will lose 2 electrons and will acquire plus 2. That is its valency. Got it? Now, chlorine. The atomic number is 17. So we have arranged 17 electrons in different shell. That is 2, 8, 7. In the last shell, as you can see, it requires only 1 electron to complete its octet. So it will gain 1 electron. Okay. And because it has gained the electron, so we have to write minus sign. And how many electrons it has gained? 1. So it will acquire minus 1 charge, which will be the valency of chlorine. In the same way, sulfur, in the last shell 6 electrons are there. So it will gain 2 electrons. So the charge will be minus 2. And the valency is minus 2. In case of phosphorus, the last shell is having 5 electrons. It requires 3 more. So it will gain 3 more electrons and will acquire charge minus 3. I hope you have understood valency concept. Now see some of the example. The first example, we are having magnesium chloride. The first step, to write down the symbols as we have written. The second step, to write down the valency of both the ions. And then we need to cross multiply it. So magnesium will get the valency 1 and chlorine will get the valency 2. There is no need to write down the sign of the valencies during writing the formula. So the formula become MgCl2. In the next example, we are having calcium oxide. First step, we have written the symbols. Then we have written their valencies. As I told you earlier in the videos that if the valencies can be cancelled by the same factor, we need to do that. So here we have cancelled these two valency by 2. So ultimately we will be getting 1 on each side. So now we cross multiply it. So calcium and oxygen both will get valencies 1. So the formula will become CaO. Earlier, the valencies we were discussing, the valencies are of single ion. The next topic we are having polyatomic ions. Polyatomic means more than one type of atoms. Here we are having some of the examples of ions in which more than one type of atoms are combined together. And we consider their combined valencies. Let's have a look on the examples. Suppose nitrite ion, here 2 atoms are involved, nitrogen and oxygen. But instead of taking their valency separately, we are taking their combined valency as minus 1. Again, nitrate, again 2 different atoms are involved, nitrogen and oxygen. Here again we are taking their combined valency, that is minus 1. The same way hydroxide, which is made up of 2 atoms, oxygen and hydrogen. But we consider their combined valency, that is minus 1. Sulfate ion, which is made up of sulfur and oxygen, and their combined valency is minus 2. Carbonate ion, which is made up of carbon and oxygen, and the combined valency of this ion is minus 2. Phosphate, PO4, whose combined valency is minus 3. We need to learn the valencies of polyatomic ions as it is. How these polyatomic ions are formed, that you will be learning in your higher classes. So till that, you please learn the valencies of polyatomic ions. Let's have a look on the example to understand it better. The first example, we are having aluminium sulfate. In the same way, just write down the symbols of aluminium and sulfate. AlSO4 is the symbol of sulfate and aluminium. Now, write down their valencies. Aluminium is having valency plus 3. Sulfate ion as a whole is having valency minus 2. Just cross multiply the valencies. we will be getting Al2SO4. Beta, just remember one thing, when you are writing the valency of polyatomic ion, you have to keep the ion in the bracket because this valency will be for the complete ion, not for the single atom. Okay. Now, sodium carbonate. Here, just write down the symbol of sodium and carbonate ion. Then we have written the valencies. Then we have cross multiplied the valencies. Na2 and CO3 here, if you are not putting the bracket, that is okay because here only 1 is present. So for 1 there is no need to put the bracket. But if the number is more than 1, then we need to put the bracket around the polyatomic ion. Got it? Because we are considering it as one ion. Fine. I hope you have understood all these examples. So, mug up yourself and get ready for the preparation of your exams. Okay? But don't forget to like my video and subscribe my channel. Have a nice day ahead.